the usual variation is proteomics to predict ferment and personalized treatment for community non-functional situated anomalous. Personalized variation are involved in each aspect of a care scale, including prediction, prevention, and the assessment preventive response. Also, the diagnosis, search, and the assessment of search to response. Also, physiological basis for the evaluation of the performance. Here is hypothalamus, here is pituitary. This picture shows the hypothalamus, pituitary cell, and the tactile organ axis system. Each type of pituitary adenoma is monoclonally arranged from the corresponding pituitary cell. This is ACTH adenoma, TSH cell adenoma, GH cell adenoma, the PRL cell adenoma. Non-functional adenoma is mostly from the galactotrophic, but some from the low cell oncocytoma, silent polytrophic, silent somatotrophic. Those are heterogeneous cells of origin of non-functional pituitary adenomas produce a difference in proteomics related to the control and among different NF pituitary adenoma patients, and that difference in the proteomic environment changed with the tumor progression. That proteomic difference and the dynamic of the region with tumor progression both contribute to the patient prevention and the personalized patient treatment. Tactile organs of proteomic validation include the pituitary tissue and the body fluid, CSF, and the plasma. Tissue proteomic. For the tumor tissue is generally from the usual surgery from patient, but control from the post-modern cadavers. If you compare the gender, age, race, and time tissue population are not consistent between the tumor and the control. Also, the tumor tissue is monoclonally in origin and generally benign, contains the relatively pure cell population, but the control contains different types of cells. If you compare the cells, types are not consistent between tumor and the control. Later capture would overcome the bias. Compared to the tissue proteomic, the body fluid specimen don't have those limitations. Whereas the body fluid specimen are much more accessible from patient and the control. Technique to measure the proteomic variation include the gel method and the non-gel method. Gel method we use the 2DG based compared to proteomics and the 2DG based compared to proteomics. 2DG is more useful to analyze the precious air-thin enriched sample because it requires laser protein or molecule and the fewer gel analysis procedure. Non-gel method is stable isotope labeling based multi-dimensional LC-MS, such as I-touch, I-touch. For gel method, there is some limitation. It's difficult to detect the extremely acidic basic protein, extremely high mass, low mass protein, and the hydrophobic protein. But gel method can detect the protein isotope. Non-gel method can detect the low abundance protein, extremely acidic basic protein, and the low mass, high mass protein. But non-gel method is difficult to detect the protein isotope. Another important technique is the pathway network analysis. Pathway analysis can denote each protein variation within a pathway network system. Technique to measure body fluid protein peptide pattern variation includes the body fluid protein pattern recognition based on cell post-MS. Another one is the body fluid peptide pattern recognition based on the multi-part MS. Somebody uses the tryptic peptide pattern recognition. The body fluid sample are first digested with trypsin and analyzed with multi-part MS. The MS spectra are compared to determine the differential tryptic peptide pattern to discriminate the tumor from controls. Whereas the signature protein peptide or their antibodies can be used to make the cloning antibody microarray for predicting diagnosis and the measurement of preventive serotypical responses. And importantly, paradigm shift changed is from traditional single factor strategy to the multiple parameter systematic change. The reason is a traditional single molecule biomarker is based on assumption, and increase in the amount of single compound can clearly specify a disease. But the reality is NF52 adenoma are characterized by heterogeneity among patients and initiated by multiple factors. Also, the NF52 adenoma can cause multiple events and recombinant alterations, and resulting in a variety of different molecular changes. But only one single intracellular pathway is involved in the molecular mechanism of adenoma. Also, no single one parameter can resolve the entire problem. For some time, one parameter is not able to resolve the problem at all. For example, increase the blood pH, growth hormone, and the prolactin has been useful to predict and diagnose acromegaly and the prolactinoma. However, a large number of patients are still detected at the advanced stage. Almost all NF52 adenoma are diagnosed at the late stage due to low blood hormone elevation. Therefore, we would like to suggest the multiple parameter biomarker from the plasma or CSF would resolve these problems. This is the output. Pituitary adenoma proteomy include tissue proteomy and body fluid proteomy and peptidomy. Tissue proteomy validation include protein nutrition validation, protein modification validation, splicing validation, pathway network assessment validation. Those validation can be used for accurate molecular classification and the personalized patient. If the personalized patient proteomic validation is corrected because the personalized treatment, the body fluid proteomic peptidomy, the part validation can be used for predictive diagnosis to get the high risk population. If the high risk population's proteomic validation is corrected because the interventional prevention, also the preventive response and the therapeutic response also can be assessed by the body fluid part validation.